Hi guys, welcome to Memo's Tutorials. We are continuing with our chemistry section, and today we are looking at indicators, where we are saying an indicator is just a substance that changes color according to the acidity or the alkalinity of a solution, right? On our previous videos, we looked at the litmus paper, we looked at the litmus paper, the methyl orange, and the phenolphthalein. And today I want us to have a look at the universal indicator. So this one is just a mixture of dyes that changes color to correspond with each value of the pH, right? Of each value of the pH scale. And these colors, they vary slightly depending on the pH of the solution. So this one, it will tell us that whenever you see red, just know that the pH is around 1 and it's a very strong acid. Whenever you see orange, your universal indicator turning orange or becoming orange, just know you've got a medium acid there between 2 to 4. So the pH range is between 2 to 4. For a pH of 5 to 6, a very weak acid, it's going to be yellow. But when we look at the bases now, before we move to the bases, neutral, it's green. When we see it being blue, it's a weak base, which is from 8 to 10. And when you see it purple, it's a little bit strong base, 11 to 13. And when it's violet, that's a very, very strong base, right? It's a very, very strong base. But then how do we identify pH values for different substances? It's very easy. You have fill 5 test tubes with each of the following substances. For example, the first one can have sodium hydroxide, the second one having vinegar, third one having lemon juice, the fourth one having hydrochloric acid, and the fifth one having distilled water. And then you add a few drops of the universal indicator solution in each beaker. Remember, the universal indicator is going to give you the precise colors. It is going to show you that this is a weak acid and it's going to be yellow. If the acid is in between, it's going to be orange. If the acid is strong, it's going to be red. If the base is too strong, you are going to have a violet, right? If it is medium, it's going to be purple. If it's a weak base, it's going to be blue, right? And then you record your results. Obviously, distilled water, we expect it to be neutral, and it's going to just give us a green color, right? So now it's up to you guys to identify between hydrochloric acid and lemon juice and vinegar to say which one is more acidic than the other. Sodium hydroxide, I'm sure you agree with me, it's a very strong base. So we can expect it to be purple or even violet, right? And then now let's move on to the preparation of salts. How do we prepare salts? It's very easy. You simply react your acids with metals. When you react a metal and the acid, what you get at the end of the day is a salt. So, when an acid reacts with a metal, hydrogen is displaced. Hydrogen is displaced, meaning we're going to have hydrogen gas being produced. And when you displace a hydrogen, you leave a salt in the solution, right? So the salt produced when an acid reacts with a metal depends on the acid that is used. Meaning when we use hydrochloric acid, we are going to have chloride salts. When we use sulfuric acid, we are going to have sulfate salts. When we use nitric acid, we are going to have nitrate salts, right? Take note of that. So on our example here, we're having magnesium reacting with sulfuric acid, and we are getting magnesium sulfate and the hydrogen gas. Where is the hydrogen gas coming from? It's being displaced here. So what really happened is magnesium displaced hydrogen from its sulfate there, and we ended up with a magnesium sulfate, which is a salt, and the hydrogen gas freely hanging on its own there. Okay, that's the same thing that happened on zinc. Zinc displaced the hydrogen there, and then we ended up with zinc chloride and